and then what you're looking for, you're looking through these six crystal systems.
Yes.
I'm missing one, but it doesn't really matter. Okay, in here then we've got between these two brackets here and this one down here, we've got our values. Now what we can do is we can send that on to Topaz. And yeah, this is where, yeah, I don't have access to your thing now, so I can't do anything. Okay, so I'm going to give that back to you.
So I need to open the...
So if you go to Topaz then, and you'll want to go to the file and close all.
Close all? Okay. Yeah. Yes. And
now
then...
if you go, yeah. That's it. And press go. Okay, so that's giving you an idea as to how things are going. You can see that the y-axis here is not getting above 6.
Yes.
That means that the solutions are unlikely to be good. Okay.
Fine.
So we can just click on OK and then go back to JEdit.
Yeah.
Okay, so what I'd suggest you do is I'd suggest that you only take the first 20. Okay, so comment out using the apostrophe. Comment out those at the beginning of the line. So say take 20 or so reflections. No, not degrees. I'm meaning 20 as in 20 peaks.
Okay, so just shall I put that comment that only 20 peaks?
Right. No. So delete all that. Yeah, okay. At the very start of the line, you'll need to enter column mode again, so Alt and then backslash. Doesn't seem to be working. Right, okay, I'll just... Okay. Right, so here we go. Say, for example, I'm just going to put a comma like that.
Okay.
Okay, that means the program's going to ignore it. So that's 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay, right, let's just do that.
So you just put apostrophe?
Yeah.
Okay.
I'm going to get rid of these ones because these are quite low in intensity, okay?
Yeah.
So obviously we're doing less than 20, but let's just go with that. And you'll need to do what you need to do. You need to run it through Topaz.
No range to fit, okay.
Okay, so we're getting slightly better now. We're up to 100. Okay, that's promising. Okay, so let's maybe look at that then. So if you open up that NDX file then in Topaz.
Okay. Load the scan file or load
Not Topaz, sorry. Load the NDX file in JEdit, sorry.
Okay. is this or shall I save it from?
So there'll be a new file called whatever it is .ndx, and you want to open that.
Shall I?
The filter on the thing says star.raw. That needs to be star. That needs to be the fourth one up.
Okay.
All the different types of characters.
Fine.
The one down from that.
And ndx peak index peak. Yeah.
Okay, so at the top there, then you've got potential indexing of the sample.
Yes.
So that's obviously 115 goodness of fit, so that's pretty good. What's promising about these sets, these first two, is that they're sort of similar to one another and the same sort of numbers are coming out.
Yes.
They're not the same unit cell because you can see that the volume's changing.
Yes.
But obviously it's promising anyway. Okay, so what's the volume that we need?
520.
What's that including then?
That was myconazole mesylate dihydrate, but obviously if it is making chloride, then the volume will change.
Yep. So what's it?
Okay.
As if it was going to be the chloride, so what would it be?
So chloride. No, I need to do the calculation. But yesterday when I was doing the dash, practicing like the tutorials within the dash, it says for each chlorine it was 25 angstrom. Like for carbon, like there was a like a table that shows each.
Okay.
I will do these. Like yesterday I did the practice within dash, so today I was doing this thing, so then I can combine both to do the to make the to practice for the indexing thing.
Okay. Well, for that, and if Dash says it's 25 cubic angstroms, then go with Dash.
Okay.
Okay. But we need to, so those are potential solutions to your indexing. So there's ones at 430 and 115. That looks okay. The unit cell seems to be a lot smaller, so you're going to have to divide that by 2. So that's 215 cubic angstroms.
Yes.
Per molecule or per unit. So is 215 ringing any bells? Is that myconazole by itself, or is that, what is that?
Shall I just quickly check the molecule mass of myconazole?
It's not the mass, it's the number of non-hydrogen atoms. That's
yes,
what you need.
Yeah. Okay, I will do the now I have a bit of idea that how to calculate the how to perform these calculations, and I'm making the sheet that I will do the document now.
So what is the purpose of this, Sadia? I understand that you want to learn how to do indexing, but we've got a potential indexing already that looked pretty good. And I'm wondering, are we not looking to try and solve the structure?
Yes, yeah, this was I was trying to follow what you showed me, and like make my own or make the file, and then I can go.
It's just that indexing powder samples is really, really challenging.
Okay.
And if you've got a good solution, it may be just that I've picked that one peak, or I might be one off here or one off here. Unless you've got really, really good data and it's really well characterized, then it can be really, and even then it can be really challenging. But if you've got a unit cell that is looking pretty promising, I would go with that and try and solve the structure. You can
And
practice indexing. You can,
sorry, so might be like I might be doing the wrong thing. So what like you when you send the email that like make the document, so that's why I was doing all this practice, that so I can make each, like I know each and every step that how to do the powder
well,
indexing.
yes, okay. I mean, and that's fine, but we need to make that's documents for yourself, right? But we
Okay.
need to make progress on the project. Okay,
Yes, yeah.
making documents of how to do something is not going to get you your PhD. What will get you your PhD is getting structures that will get your data. That is what's going to get you your PhD. Now, the creating these documents and sort of that was whatever 2 weeks ago that we did this. I would have expected that document turned around in a day,
Yes, yeah.
like a day or two, and you should have had that document to me. I could have commented on it and come back to you with it. Now, I'll
Okay.
continue to feedback, I'll continue to comment on documents, but that's 2 weeks ago that we did that. Is it about 2 weeks ago?
Yes,
Or
yeah.
is it a week?
Yeah, it is 2 weeks
2 weeks?
Yes.
Right. So that's 2 weeks where we've done no progress from this line of work in your PhD.
Fine.
Yes, it's fine that you're doing this and you learn how to do these indexing procedures. That's great. But that needs to be done in parallel with actually moving forward. Because I think that powder indexing, whilst it looks promising, it may turn to nothing. And if it turns to nothing, then you've just wasted 2 weeks, or not wasted, but there may be other solutions here that could be viable. But that's time that is just dead. And you've had all this week, you're saying you were going to be working on your documents and things like that, and that's fine. But again, it's this type of activity on your computer, trying to solve crystal structures. That's all computer-based activity that can be done at home and or in the lab in the university.
Yes.
So really, I would strongly suggest that you follow one of this. I think it's hydrochlorothiazide. I think it is an
Yes,
example in Dash.
Yes.
So with the solution that you have, the unit cell that you have from when we did that, you
Yes.
can input those parameters into Dash. You don't need to index the sample anymore. You can just put in known parameters.
Fine.
And if you put in those known parameters, then that gets you to the next stage.
Fine.
And obviously you have, so when it comes to feeding in the molecules themselves, you will obviously have PIP, I think, could be used as a miconazole, okay? And then you could take any hydrochloride salt from the database, any CIF file with a hydrochloride salt, and put and open that CIF file in there.
Okay.
So say, for example, if you do epinephrine hydrochloride, okay, let's say you just put that CIF file in, there'll be two components, okay?
Yeah.
One of those components will be epinephrine.
Yes.
The other will be the chloride ion.
Yes.
Okay.
Yeah.
So you want to delete the epinephrine.
Yes. Yeah.
Leaving only the chloride.
Fine.
Now, I think there's also water potentially present in this.
Yes. Yeah.
Okay, given the volumes. So it may be that you want to put in 2, 3, 4 water molecules. Again, put in any hydrate structure, anyone at all, and then delete the pharmaceutical, leaving you with the water. And you might need to input, so the water itself will have a Z matrix. And so if you can open the Z matrix file. Okay, so I can quickly show you how to do that.
Please.
Just now. Okay, so if we look at this then, okay, so where are we? myconazole, is it?
Like basically it was on C drive, like you save it in C drive. Are you looking for the data?
Yeah.
It was you saved in C drive.
Yeah, this is on my PC though. C drive is in your PC. It's okay.
Okay.
So what we can do then is we'll just open up one of these files. Okay, so here's your file. Okay, so
Yes.
we can click through most of this. So what you'll want to start to do is you'll want to add in known cell
Okay.
parameters.
Yes, yeah.
Okay, and then you can type in the cell parameter or copy and paste the cell parameters into here.
Fine.
Okay. Now, what I will do is I'll just put in this, for example. So that's pip. I don't know whether that's right or not. It doesn't look to be the right thing. But that gives us the unit cell parameters in here. And you want to choose the correct space group. Okay, so this will potentially be whatever it might be. Okay. And then, for example, we're using our mouse, dragging over. So this is in the tutorial. So you'll drag over.
Yes, yeah.
Drag
now,
over.
yeah.
Using your right-hand mouse button. And you just want to pick peaks right across the diffraction pattern to be able to do this, okay?
Yeah.
And click on next. And we kind of come to some sort of a refinement. It's going to be nonsense because it's not the right unit cell. It's not, it's just going to be rubbish. But I'm just wanting to get to the next screen.
Basically, when I was trying to do it for hydrochloroside, I performed all these steps following the tutorials, but at the end when I was like I run the sample for indexing, I don't know, it was giving some kind of error, so I stopped at that point.
Well, sure. I mean, the indexing. If you've got a known unit cell parameters, then you should be able to input those. But for example, this gets you past the poly refinement. So if you've used the unit cell parameters with your data that you have, then you should get nice, good chi-squares, very low chi-squares. This isn't working particularly because it's the wrong stuff. But what we then do is we go onto the solve button, and in here, this is where we're talking about putting in PAV-PIP, for example.
Mm-hmm.
Now, what I can do is I put in my so I put in my CIF file, but what it does do is it converts it to a Z matrix, and I can view this, and what it'll do is view this in Mercury.
Okay.
Okay, so it allows me to see what the material is. Equally, it tells me how many degrees of freedom I've got. That's 12. Okay, so I know that there is a molecule in there is this? Yeah, here it is. Okay, so it's giving us a view of what we're putting in. Okay, so I now know that molecule is correct. That's the one I want to put in. Okay.
Yes.
Now, what I did say is I also want to maybe put in hydrochloride or something like that. Okay, well, we can do that. Let's just use this. I don't know what this is. Okay, what you can see here is this ET1 or whatever. There are 3 molecules in that.
Yeah, that is myconazole nitrate.
Okay, so that's the myconazole. So it's possibly a couple of nitrates. So you can see the 1 matrix and 2 matrix, they've got 6 and 6. So they're likely to be the same thing.
Mm-hmm.
But I'm just waiting for this to fire on. Okay, so there's my nitrate. Good.
Mm-hmm.
But I've also got another nitrate that is going to be here as well. So I can view this if I want to, or I can edit it and say, oh, that's NO3. Okay, I know that's nitrate.
Yeah.
NO3. But I've also got my myconazole here
as well. Yeah, that's
okay, so you can see that's there, right? So if, for example, I want, say this was a hydrate, not a nitrate, say it was a hydrate that we put in here.
Yeah. So then it will show the water, and we
can. So I have water in here, and it will have the miconazole.
Yes.
So we don't want 2 micanozoles in here.
Yes.
We
Yeah.
only want 1.
Yeah.
Okay. So I'm going to just delete that last one.
Yes. Yeah.
I'm going to delete that one.
Yeah.
So I don't want that either. And how many waters do I want? Well, I might want 2. Therefore, I've got 1 water molecule and 2 water molecules.
Okay.
I might want a third.
Sorry for interrupting. So if it is showing like I want 2 water molecule, but it is showing 1 water molecule, how I can add another one?
Yeah. So I'm just so here, if you open this up on the blank tab here, what you'll have here are your Z matrices. So you can see matrix 1 and matrix 1, Z matrix 1 and 2. Sorry. You could either import either one of these, and that adds in another nitrate or water. Okay. If we want to add in another one, you open up and you highlight that Z matrix. Okay.
Okay.
And therefore you have got miconazole,
nitrate, like
suppose four nitrates or whatever.
Fine. Yeah.
It's obviously rubbish, but
Yeah.
in this case it would just be water.
Mm-hmm.
In the case that you're wanting. Then it's a case, but what you want to do is ensure that you've got the right number of molecules in there. So if you think it's a chloride, you put in your chloride plus 2 waters, 3 waters. And then you can click on next. And a lot of this is just next. Click on next and solve, right? And what it'll do is it'll go off and try and solve the crystal structure for you.
Okay, fine.
Okay, which is now struggling to do, but yeah. Yeah, it's just going off and starting to do that. Okay. So
Yes.
see how you get on, and if you're struggling, then say come back to me and/or
Yes,
speak
yeah.
to others in the group, Martin or I guess Martin or Alan. Martin might know as well, or he should know. But you can see it comes up with some sort of. This is something you can put on overnight. So the last thing you do, whatever, 5 o'clock today, you can set this thing going, and you just let it run overnight. Keep it going. Don't close the lid of your laptop. Put it up high somewhere in a room somewhere that your doctor can't get it.
Yeah.
So just let it work over that period,
Yeah.
And it means that the thing is doing its best,
Mm-hmm.
and it will do what it needs to do.
Fine. Yes. Yeah. I will do this today. One thing more, from Monday I will do my Easy Max experiment. Like I book it for a week, but the problem with the last experiment with the last experimental set is like I when I put my sample for the HPLC solubility testing, the peaks, they were very high, like it was too concentrated sample, but it was left overnight, and when the next day, like I did the dilution, I saw that it have precipitates in it. Like actually basically it was a buffer solution, and like my miconazole mesylate dihydrate was in a buffer solution, so it was doing the dispropanation in the vial as well. So I thought that might be there was a problem in filtration, but then when I saw that it was in all of my at the base of all the vials, it have precipitates of the product, like which I got in the EasyMax beaker as well. So the thing is that now I need to repeat that, like, and the point of doing repeating is because it will include the investigation that my mesylate dihydrate, it will not dispropanate in the mobile phase, because I will do the dilutions in mobile phase. So I will take the sample, but I need to dilute it. Like as long as I will take it, I need to dilute it, and then need to, this is the thing which I learned from, like I wasted my 3 days, I know, but the thing which I learned from there is that I need to take the sample, dilute it straight away, and then put it on the sample, because otherwise it's gonna keep on disproportionating, and that will not be the accurate value. Like, yeah.
But make sure, make sure you've got. Of that solid, what's the solid look like? Is it a powder, or can you get a single
That was a
crystal out of
powder.
it?
That was a powder, but I have got the single crystal of this product as well. Like when I was extracting the sample, like a very small bit, I put it for crystallization, like to dry it, and got the single crystal. And I have got the single crystal for almost all of my like 3 experiments which I have done. From Monday, when I will go back, I will do the single crystal, and obviously like will have that solution as well alongside.
Right, okay. So, as soon as the diffractometers are up and running, then get that on the diffractometer, because that will help you with your, hopefully it will be the same product, and then there's no need for indexing or anything like that. We know that it is that.
Yeah, so yeah, these are the things like which
Okay.
like from I will on Monday, I will repeat this, the reason that I like it start disproportionating in HPLC vials as well. So I will repeat this, but I have got the details for my that was in 3.6, and now I'm going down backwards towards for the pH 2. So
Yeah.
now I know that it is disproportionating at 3.6, but now I know that what is the least pH where it is stable. So like that's the
Okay.
the thing which I have planned.
Yeah. Okay.
Yeah.
I'll just keep a note of the observations you've got as well, and those visual observations are good as well to have.
Yeah, so these are the plus like last week what I did, like I need to earn the 10 credits for my PG cert, and it was the deadline for the submission of for the supervisor to send the like there were 2 assignments. Like one was it was writing and presentation. So one was the writing the extended abstract, and the second was selecting the papers where you want to for your 3 publications, and the draft of your thesis, that what chapter will you include. And like I did it roughly, like but yeah, like I selected acta crystal, ACS, American association. Like one is that, and the second was the um, Elsevier, like where like why I selected like one, I propose that I will publish the pH dependent solubility experiment, like what I'm doing, like what is the intention, so that we can prove that our dihydrate. The other is the crystal structure, like the novel water bridge salt hydrates, what I'm proposing. And the third is because we are proposing the definition of water bridge salt hydrate plus the classification. That is another thing. And I will send you over the my searching criteria within the CST for the motif searching of the water bridge salt. This is the work which I have done this week, like for that, like to come up, like this time I will make the assignment by this Thursday. So like I want to break my presentation into 2 main things. One is the disproportion, like the pH dependent solubility experiment. We will concentrate half of the meeting on this. And the second is I want to focus on this water bridge salt hydrate definition plus the classification, because now I have some kind of idea that how these like how we can make a motif, and then we can put it to a search. So like I can ask them to give me an idea, like so that we can build up that thing. And that like
Okay, they will not. David's the only one that will have any idea about the kind of motif searching or anything like that. So I think that for the rest of them, they'll just want a concrete, this is how you've done it. Okay, so David's the only one that would be able to guide a little bit and
like
have an idea as to whether that's okay or not.
Like now I have made myself a bit to ask question, like I know something, so that I can cross question that, okay, I know this, if you can please guide me this, then
it's a question. I think it's at a stage where you need to propose something.
Yes.
And then people will say, yeah, that sounds reasonable. I think that's the stage that we're at, that we need to get to.
Yes.
Okay.
Yeah. And sorry for all this,
It's fine. It's just you just need to learn how to work the topaz. I mean, it's difficult with different computers and different setups and stuff. When I say control back or whatever it is, I know that's how you do it, but and you need to, it's only by doing that you're going to be able to do this. Me showing you how to do it, you're never going to learn.
yes, yeah.
Okay, it is a mode of learning, but you're never going to learn.
Yes, yeah.
You've got to do it, and you've got to muck around, and you've got to make an error. You've got to change this, change that, and see what errors you can make, and then you can correct yourself.
But like, yeah, I found that this thing, like, that is, I'm more interested now in this thing, like which you showed in the ritual refinement, like the peak positions. I really wanna learn this, like first I wanna learn from you, and once I will get something, then I can ask Alastair. Like, first I need to cover up all the things which I can learn from you, and then
Yeah. Okay.
yes.
Fine. Well, have a good weekend.
Thank you so much. Thanks.
Okay.
We'll see you next week.
Okay. Bye.
Bye.